So Gregg Langling is our speaker this evening, and Greg will be talking about the new improved voting system with the repeater. There have been a lot of changes and improvements to the repeater system. This is a series we're doing, so take it away, Greg.
Okay. Give a minute here for my partner in crime, Paul, to start sharing. There we go. Well, we can go ahead to the next slide. The idea of this years ago was to design handheld coverage for the county. And you can see that this is a basic block diagram showing you the main repeater antenna at the top down to the duplexer. But we have 5 other receivers that are at different locations: Belgium, Grafton, Mequon, Port Washington, and Germantown. And those all feed into that LDG voter, which is the block that's straight up in the center. And what that does is it looks at the signal and measures the amount of high frequency noise. If you listen to FM signals, when they're not full quieting, you start hearing white noise. That's what we're measuring. And so as we go on in here, we'll show you how we measure that and how the system handles that. Next slide, please. Here is just a quick look at the main rack, all the radios it takes. There's an exciter, there's 5 UHF receivers to receive all the link sites. There's the main site receiver, and then there's also a control receiver that we use so we can control the repeater without you hearing touch tones over the air or bothering anybody. So that's the main site. All of those slide out. So there are connectors that we can, everything's broken out and it's easy to test or replace equipment. Next slide, please. So what happens on the remote sites are there's 2 antennas. There's a receive antenna and a transmit. And you'll see there's an RX antenna at 146.37. There's a Motorola VHF receiver that goes into an SCOM 5K controller, which controls it and puts the information of a valid signal into the Motorola UHF transmitter with a Yagi. And that's received by one of those 5 UHF receivers back at the main site. And the core, the carrier operated relay, the valid received signal, the audio and that logic signal are sent to the voter. Next site. And right there, that's what a remote site looks like. It's just 2 radios and a controller. And there's a receiver there and a transmitter, VHF receiver, UHF transmitter, and the SCOM 5K. Those are very basic controllers, but they do everything. And they have a special tone board in them. So we only send the PL tone when the valid signal is there. We leave it up for a squelch tail, but not with the valid signal, no tone. So that eliminates all the crashes when you're on key. Next slide, please. Here's a map. And you can see pretty much in the center, straight, you see that one pinpoint that's straight east of Jackson right there. That is the main site. That's where the main tower is. And then we have our receivers at Mequon Park on the county tower, Grafton at the Grafton Firehouse, one up at KK and LL in Port Washington that right now we're waiting to get the tower climbers up there because the antenna, either through storms or through negligence of tower climbers, is broken. And it's a commercial site, it's a cell site, so we have to pay a tower crew to replace that antenna. So that's offline. And then there's a receiver up at Belgium on the county tower up there. Next site, please. Oh, Germantown. Yeah, and that's a donated site from our field day chairman, Nate, KC9TSO, who's also on Zoom right now watching the meeting. Okay, thank you. Next slide. This is actually a coverage map. The green is all high enough signal. It's 0.3 microvolts. And for most ham radios, if you're receiving 0.3, that's full quieting. So that green, all there, should be a full quieting signal. You'll see down in New Berlin, there are spots that are green. The yellow is three microvolts, not 0.3, but 3. And so that gets pretty noisy. You're down at 12 dB to 10 dB quieting, and it's a little intermittent. But that'll give you an idea of the coverage we have with the way the antenna is designed and everything. And the reason why it looks like it goes out over the lake more than it goes inland, even though we have an array pointing southwest, is because of the big ridges out there. You got we're just barely over the highest point of Osage County. But when you get out to Washington County towards Highway 41, you're climbing, and there's a big ridge that comes through there. And that's why you see the cutoff after West Bend and Slinger and everything. And no, next slide. There's the basic voting system. You can have up to 8 receivers on our boater. And you'll see I have receivers 1 through 8. There's a special CT CSS board for each of those link receivers and the main side receiver, so they all act identical. And the push to talk, basically the valid signal and the audio is fed to the RVS-8, the voter. And the voter does all of its fancy magic, which we'll get into, and then routes the correct audio signal from the RVS-8 to the SCOM 7K, which actually controls the repeater and keys the repeater, does the identification. Next slide. So the voter requires 2 inputs: discriminator audio from the receiver without filtering, no filtering, because we need that high frequency noise, the hiss. The COR, which is called carrier operated relay, but basically in our case, that's CTCSS being detected, the 127.3PL. And then that received audio is sent down 2 paths in the controller. Path 1 is a high pass noise filter. And after that filter is where the noise measurements can be converted to a DC voltage. And path 2 is recovered audio that'll be sent along to the repeater controller, which is pretty well filtered for 300 to 3000 hertz. Next slide. And here it actually is. The op amp you see on the far left is actually the recovered audio that's being fed to the controller. That's the actual receive audio we're going to use. But the second filter down there in the center, that's your high pass filter. That's them feeding a voltage comparator. The one chip is a op amp, the other one is a voltage comparator. And that's where we get our reference voltage that measures the amount of white noise on the signal. The more white noise, the higher the signal. The less white noise, the lower the signal, which you'll see later on. Next, please. So basically, this is just the level sets I talked about. We're setting it up first, our audio level for the voted signal. We'll send a test signal at kilohertz, 1 kilohertz with 3 kc of deviation. So we can set it up so we have 1 volt peak to peak coming out of those op amps. So all 6 receivers that we're running right now will have the exact same amount of audio coming out. The second one is to set the noise level with no received signal. So we're actually just squelch open white noise. And we'll set that to a voltage of 3.5 volts DC, but we've changed that down to 2.5 after some experimentation. And those voltages will feed the digital analog converter inputs in the process. This was built with service mount 3/4 turn 100K pots. Can you think about how touchy 100K pots are when you're tuning them? Not only that, what happens when it's 80 degrees in the shack in the summer and 20 degrees in the shack in the winter? Those values change. So on both this voter and the spare voter, we threw those away and put in 10 turn pots. Yeah, that now really helps to set that noise level. You're going through the TLO 84 op amps for you that are available with that. But then we go to the MOSFET op amps where we're doing a comparator. We're changing that audio noise to a DC level. Next slide, please. There's an 8-bit processor that's the heart of the system, and it looks at all of the D to A inputs, those noise inputs. It looks at the associated signal active inputs, and it looks for which one of those has the lower voltage and with less frequency noise. And when it reaches 20 dB quieting with no noise, it's going to go down to 0 volts basically, which it may show up at 0.01 or whatever. Then there's a hysteresis setting that you set for how much improvement you need on another site before it goes over. Let's say the site you're on right now is at like 0.2 volts, and there's another one at 0.19. Well, it's not going to go over there because we set the hysteresis to a different level. It's got to get down to like 0.1 before it'll vote over to that one. Otherwise, you constantly have it voting. We do have a little bit of voting when you're on the main site. Some ham radios from the factory come with a higher mic gain and audio output, and they're deviating over 5 kilohertz. And if they do, they can go out of the passband at times for a second on the main site, and so they'll plop over to another site. I notice it with people that are on a lot of sites at the same time, like the guy with the twin 11s running 1.35 gigawatts or whatever. He'll be in the main site, but then all of a sudden you see him plop to Mech 1 and then to Belgium and then back to the main site. And we all know Don's got a big mouth, so he does get a little loud at times. So can we go to the next theory page? There's also disable inputs, and we can disable a site if it's acting up or causing problems remotely. The 7K controller lets us do that. And that's one of the nice features about having a control receiver. We can go on that special UHF frequency, even when the net's going on. And when we found out the antenna was broke at Port Washington, well, right away, put the code in and just shut that off because it was causing problems. Because Stan lives so close to the site, even though all there is a stub of an antenna, he can still get in, but not real good. And Don can get in, which is a miracle. But we do have the antenna, so we can do that. And each remote site also has codes that we can go on 9.7, and there's a special code, and each remote site has got a different set of codes, so you're not doing it to all of them at the same time. Well, we can disable that whole remote site so that transmitter doesn't even come up. Whereas the voter, when we turn the voter off, that link is still transmitting. Next slide. Too many pages of theory, not enough pictures. There we go. There's the voter. And I don't know if you can see real small down there in the display. It says receiver 1 is the current voter receiver, which is the main site. Now, we brought out, I put a bunch of voltage displays there. You can see right now that this is when we first started setting it up, that you can have 0 volts on one of those, but if you don't have a PTT, it's not going to look at it because there's no noise coming through. But you can see right now that it's voted to 1, so the main site's at 0 volts. KK and LL's not bad at 0.22, but Belgium really sucks. It's like all noise, just barely opening the squelch on that one. So we can see all of that. We've got cameras on it, but Paul here has some great ideas and is working with me. Well, guess what? Over the last week, this guy just jumped on the bandwagon. We'll get around to that. Paul's going to finish up this talk. Let's go to the next slide. So this is just a picture of the processor and where all the inputs are, the noise levels coming in, the core and disable inputs. And it's really a really neat, compact little package. Next slide. Go the right way. Oh, that's same picture again. Oh, there we go. That's the actual input. And if you see those 8 blue things up in the top left corner, those are the 10 turn pops to replace the 8 yellow ones below. Those are the audio, the transmit audios. Those are the 3/4 turn 100K pots. But up where we're doing the noise measurements, we put in the 10 turn 10Ks. And don't worry, we didn't spend a lot of money. I think the bag of 20 of them or 2 bags of 10 of them cost like $6. You know, they're Chinesium, so they work though. Next slide, please. This is now Paul's turn. I'm going to give the microphone to
Can you hear me okay? All right. So I was over at Gregg's place because he's volunteering, maybe sort of volunteering. I'll pay him for the parts to fix my power supply. And he said, hey, I'd like to get some more information out of the voter and also be able to control some things remotely on the voter. So started looking at the circuit like he was showing of the voter. And I had some experience professionally with Internet of Things and tinkering around with some web connected electronics. So long story short, been using some Wi-Fi microcontrollers. And I quickly over the weekend put together a little breadboard with this wireless microcontroller and some interface circuits to protect its inputs. It's only 3.3 volts, but the outputs from the voted signals are all 12 volts. So anyway, we went over to the repeater site on Tuesday and hacked my little prototype into place in the voter. And so far, so good. It seems to be working okay. I don't know what else you have in your presentation to show what we did, but I was sending Gregg, I was showing him, I wrote a couple hundred lines of code for the microcontroller, and then I wrote another bunch of code. So the microcontroller is all in C, kind of Arduino-like language. Oh, it's only $18 for that little microcontroller. So it's like, there's no brainer there to use something like that. And like I said, it's natively web connected, so it goes through you're good. It goes through their cloud system to establish a data connection. If you can go back one though. But anyway, the data goes to their cloud. It's a company called Particle. And then I have another server that connects to their cloud system, gets the data, parses it out. This is using a tool called Node-RED. And there's actually a pretty active ham radio community around Node-RED. They use it for creating dashboards for radio activities, solar activity. They use it for controlling radios remotely, getting rig information. I see a lot of messages on groups.io in the Node-RED ham community for interfacing with Flex Radio. But anyway, I've developed a lot of things with Node-RED, so it was pretty easy for me to create what they call a flow. It's basically a graphical programming tool for event-driven data. And data comes in on the left as raw data from that microcontroller via the cloud, gets parsed through a bunch of conditional things to eventually create a map that has the points of the main site and the remote sites on the map And then based on the inputs going to that microcontroller from the voter, namely what's been voted, what the PTT is, and the analog values, then that's reflected on a web page. So there's if you can go to that page, the address may change, it's still in development. But we can probably show it live real quick. I have no, not that one. Yeah, if you share that web browser window. But anyway, yeah, so it's not, you gotta share it, Greg, you gotta share it on Zoom. But anyway, we're still toying around with it. There may be still some hardware tweaks that are needed. There you go. So before you key up, well, there you go. What you're seeing here is, whenever a site is voted, it'll draw a line from the main site to the voted site, and the voted site will turn green. And then that little clock there just showing the last time there's a transmission. And then when Greg keys up, it'll show that the main site PTT is on. And you can see when it'll key off and then it'll revote. I don't know if you could change your power level. Maybe you can turn the power down and see it only vote to the main site. But anyway, this is a way of seeing the data that is shown at the repeater site that Greg and Tom can look at with the webcam, but here it is kind of a live web view. We've got some other ideas. Go ahead. So we got some other ideas about once we get this connected to the 220 system and the 10 meter system to also show information about those units being keyed up. But you could see as he's talking, every 5 seconds it'll reflect the values that the voter is seeing on the page. That's it. Anything else you want to say?
Well, before you clap too much, I know we all want to get the meeting over so we can go have a couple beers, but are there any questions? I can't believe I told you everything too good. What you got? Just a second, Bill. I'll walk over by you so you can talk into my mic. I'll just walk around.
I was just curious about the C code that you wrote for the microcontroller, right? What are you doing with that exactly? Is that how you
Who needs a mic?
Microcontroller is reading the outputs of the voter that is saying what site is voted. And it's also tied into those, Greg showed those analog meters that are showing the signal levels. It's also reading those exact same analog values and basically encapsulating that information up to send to a cloud site. So that the C code is really.
so the C code is basically comparators for everything, comparing all the sites.
Well, the voter does that. It's just literally looking at if an output of the voter is on or off.
Okay.
Was there somebody else over here that had a question? Oh, Fred, just a second.
Is that webpage available on our website to look at?
Paul is going to encapsulate it so it's
think you're gonna do
viewable.
I think you can, I think, we were, that was the ultimate point, is to have this embedded on the ORC webpage.
Right, and that's something we have to work together because I run the web page and we'll have to get the stream to come from the cloud over to the web page to encapsulate it on the web page. But right now it's a separate one, and there's always going to be a separate one because there's going to be some control functions that we'll have on there that we won't put on the web page. Do you have a question, Tom?
Comment. This is really far more sophisticated, I think, than any of us really realized. And it's a special thanks to all of you who've been involved with it.
Oh, thank you.
I have a question.
I think that's it, everybody, isn't it?
I have a question.
Who's that?
It's Gary W9DHI. Remote.
Oh, on the internet. I'm sorry. Hi, Gary.
Yeah, I've heard of the particle. I've never done anything with it. But I'm kind of interested that you use the particle server. Is there a monthly charge to use that server?
No, for like small organizations or individuals, you're allowed up to 100 devices and 100,000 data operations a month for free. So we have used our 3,000 data operations. Not too much. No, it's for, I would say for like an individual, you having one or a few devices, unless you've coded it where you're sending data way too fast, you probably won't hit that limit.
And Gary, I'm always looking out to the money. So, you know me, I try to save the club as much money as possible.
Appreciate that.
I'm spending all that money on tower climbers.
I have a question.
Yes, sir.
And this is basically for you, Greg. You showed a number of schematics early in the presentation. Were those lifted from the various commercial products, or did you actually build some of those from scratch?
Most of the schematics, yeah, they were lifted from the manual. Those are all the actual schematics from the manual. Like that's actually part of the manual that's explaining the theory of it. But LDG that built this, they don't build it anymore because the processor is no longer available. But
And that was why you were searching for op amps, apparently.
all of those are still available because I've already had some of those go bad, where instead of being at 0 volts, they had a constant output of like 0.2 of a volt or something, which was screwing up the voter. That's one of the problems we have with the voter, and nobody figured that out before. But a year ago, the voter worked worth crap. And if you listen to it now and watch it on the internet or via the cameras, because we have cameras up there too, we can see it voting and hardly hearing any difference at all. You don't even know it's switching.
Good job, guys. Really good job. This may be the finest voting repeater system in the area.
Thank you. I think I'll turn it back over to El Presidente.